Hello everyone, my name is Damian Wiley. I lead product for Amazon MSK, which stands for Amazon Managed Streaming for Apache Kafka. Today, we will be traversing the business cases for real-time analytics and diving into the depths of how real-time systems are achieved. I'm joined today by Adrian and Anand from Adobe, who will show you how Adobe is responding to their customers in real time using Apache Kafka and Amazon MSK. We'll go through a few housekeeping items here. By the end of this presentation, you should be able to describe why your business needs to be reactive to data by capturing and processing it in real time. I will start at the macro level to discuss how things are evolving within technology and to describe why data analytics is increasingly happening in real time. We'll segue into Apache Kafka, why it's popular for data analytics and messaging. AWS has a fully managed service for Apache Kafka, so we'll discuss what it is and unveil some new features that we've announced over the last couple of days. And then midway through, I'll pass the baton to Adobe, who will describe in great detail how they react to their customers in real time using Apache Kafka and Amazon MSK. There's a number of sessions this week that are going to interest you if you're interested in getting your hands dirty with MSK, or if you want to just learn more about Apache Kafka and how other customers are deploying it at scale within their organization. I encourage you to check out these sessions, and if you have time in your busy reInvent schedule this week. I said I would start by talking about the evolution of technology, and I'm going to bring it home a little bit for me. When I grew up in the 80s, to describe how things have evolved to where we are today. When I grew up, I had a rotary dial phone that I used to call my grandma, my friends, and family. My parents drove an Aerostar van to haul us kids around to and from soccer, baseball, school. Gas mileage didn't matter. Cruise control wasn't an option. And in-dash cigarette lighters were standard. My gaming platform, you might recognize this, was state-of-the-art for its time. It was a IBM 386. They ran Microsoft DOS. I couldn't play games with my friends on this machine because obviously internet wasn't available, or it could have been available, but modems were out of reach for me, and that machine did not come with a modem. I thought I had the best games at the time, including Space Invaders, Doom, King's Quest, Qbert, all of which depended on a 5 1/4 or 3.5 inch floppy disk. One thing if you look at these technologies and you compare them to today, at the time, these technologies were very isolated to the physical world. Individual machines and inventions were all evolving at their own pace within the physical world. Data was not being collected and reacted upon from these devices, from these machines, because there wasn't an easy way to collect and distribute this information and analyze it. Now, I have a 17-month-old daughter, and when she grows up, in the next 4 years, here's what I expect to see. First, not a surprise, and this is already probably the case today, is that smartphones will almost have already replaced the landline phone. That rotary phone that I had mentioned earlier will be a hip item. You might find it in Goodwill if you're lucky. While it remains to be seen today, I bet we're going to have self-driving vehicles taking my daughter to and from school, to and from events, to and from her grandparents' house. It's likely that she'll be playing lifelike games with thousands of her friends online versus playing Space Invaders by herself. Over the last 30 years, we've witnessed a significant change in technology driven, what I believe by, is the collection, the distribution, and analysis of data. So what enabled this? Well, I believe it was the speed and distribution of information thanks to the internet and advancements in networking technologies. 5G being a great example of that. Networking catalyzed these innovations and accelerated the pace in which these technologies evolved over time. Let's walk through this cycle. Networks, like the internet, enabled engineers like yourself to deploy applications, and at the same time, these applications could collect data in which would take that data back. You could deliver it back to home base, where you could do analysis on it, evolve that application again, or build a new experience and complete that cycle. And then the cycle would continue and accelerate. And what happened was, as this cycle continued to evolve, is you made better experiences for your customers, and this also resulted in happier customers in the end. At Amazon, we love flywheels, so I coined this the data flywheel. For most businesses, this flywheel is accelerating exponentially, which means the applications, those devices, those machines critical to a business's success are becoming increasingly reliant on data collection, analysis, and insights, which then leads to rapid development of these technologies. Meanwhile, there's immense pressure from your customers, also from competitors, to complete this cycle as fast as possible. Your customers want friction to be removed now, and whoever removes that friction the soonest is likely to have an edge. Here's evidence that the flywheel is in motion, accelerating very quickly. There are some statistics that were shared from IDC about what the data sphere is going to look like in 2025. Today we have smart everything: doorbells, cars, trains, fridges, ovens, vacuums, you name it, everything is smart, which isn't a surprise to see some of these statistics that these devices, as they run, they're gathering data, and there's more devices and more applications. So you're seeing an exponential growth in the amount of data that is within our data sphere. It's estimated to grow at 61% year over year over the next 5 years. IoT is enabling this technology to become, or IoT is enabling technology to become more ingrained into your daily lives. When you go hiking, when you go biking, when you're going to work, you probably have a watch that's counting your steps. This technology is still in its infancy, yet it was more or less mainstream over the last couple of years. Yet 90 zettabytes of data will be generated from internet-connected devices and IoT devices by 2025. I don't typically talk in terms of zettabytes. I don't know of many customers that do, but a zettabyte is equivalent to 1,000 exabytes, and an exabyte is 1,000 petabytes. That is crazy amount of data being generated from IoT devices. It's also not a surprise that 49% of the data that is collected or generated is going to be in the cloud. And that is because of organizations like AWS that provide you as a customer more value to run your applications and services in the cloud compared to on-premise. The last statistic here, I believe, is the most important one. 30% of the data is going to be collected and analyzed in real time. Here's why that's important. It's important because when businesses are reacting to data in real time versus days or versus hours, you and me benefit. Those businesses are able to react to us, provide us with more value than they otherwise would on stale data, improving your life and improving my life at a faster rate. Businesses in pursuit of better experiences for customers are going to need to climb up this curve and not only just climb up the curve for their end applications, but also for their internal operations. They need to become more efficient, produce more value, increase the utilization of resources. Businesses cannot get there by working with data that is days, hours, months old. To achieve this, businesses need to be working with the freshest data. They need to work with the data when it's generated, process it, and get value out of it immediately. Reactivity will differentiate your business. You no longer should wait 24 hours to get an answer. How many of you have asked, hey, had to go through this in your head, I got to wait 24 hours to get an answer because that batch job has to run. We can't interrupt it. Well, data streaming technologies like Apache Kafka provide the frameworks and the infrastructure that enables you to get insights out of your data in real time. They exist to help you ditch those batch jobs and react to data from your customers, from your business operations, so that you can continually evolve and become more competitive and provide more valuable services to your end customers. So here are a few high-level use cases of why you may want to capture and process data in real time. First, to wow your customers. We're in this age of providing real-time experiences to customers. If you want to wow them, most commonly that's going to require some intelligence gathered from data as customers are using those interfaces, such as a TV or maybe in a retail website where you want to serve up the right pair of shoes to that customer that they're most likely to buy. As we adopt more and more connected services that are widespread into our daily lives, there is more risk associated with the intruders out there that are looking for access to your data. You need to instrument telemetry within your networks so that you can immediately respond to anomalies within your network. You could potentially use Apache Kafka, for example, to collect that telemetry from whatever you're measuring in the network, what then allows you to detect anomalies and react to them in real time rather than in days, because as you know, if an hour can really wreck a business or impact a customer's experience from a hacker who's come into your network and wreaked havoc. You also might have a business that's sensitive to the environment, maybe wind, maybe temperature, vibrations, etc. So you may want, again, to take the telemetry from sensors in the field that gather this information so that your business is reacting accordingly to changes in the environment. If you're collecting data in real time, even just collecting it gives you that option value as a business to react to it. For example, maybe you have a marketing campaign that is instrumenting telemetry. You have telemetry from a marketing campaign, collecting that. You can tweak that marketing campaign if you know how it's performing in real time to optimize the value of that campaign. And then finally, data streaming technologies allow you to boost your agility as a developer or within your development teams. Because, again, this provides you with option value. It provides your teams the ability to build new applications on data streams themselves. And I'll walk through some of those use cases here in detail. But it allows your teams to move faster because the data stream itself provides a nice decoupled way of collecting information in real time and then also serving it out to applications in parallel. There are three components, three pillars of a real-time analytics system that I'll walk you through. First is obviously the data that's produced needs to be captured and then processed all within a matter of milliseconds, otherwise you're not dealing with it in real time. Data must be durably stored and buffered for a specific period of time so that your applications can read from this data in a way that doesn't introduce contention with other applications, so that you have this nice independent I/O experience on it. Otherwise, you'll have to chain things together to achieve the processing across multiple applications. And then finally, data must be captured and processed in the order it was produced. And the reason that's really important is because order within a data stream, for example, lets you know not only what happened, but also the relativity of one event versus the next event versus the next event. It lets you tell a story from the application side, or on the application side, tells a story about the user if you know exactly what happened in the order of those, as those events were generated. Data streams are the construct that lets you achieve those three objectives. At the heart of a data stream is essentially a commit log, which is a record of the events that were produced from a producer. The data stream lets you decouple those producers and consumers so they can work independently of each other without contention. They retain data for a specific period of time so that you can replay data. You can have consumers working at their own rate within that data stream. When a producer writes events to a data stream, ordering is preserved in the order in which that producer wrote the data to the stream so that the consumers actually get the same sequence of events for their processing. And then finally, data can be produced, committed, and consumed all within milliseconds, enabling you to achieve reactivity within, real-time reactivity within your architecture. A couple of other concepts of a data stream that, if you're not familiar with, is that data streams are very scalable. They can scale up to support gigabytes a second of throughput. The way they do that is the notion of a partition. Each partition is effectively sharded out onto, potentially onto different virtual machines, and you could have hundreds of virtual machines, which enables you to get a lot of I/O out of a data stream. And then finally, a data stream is really, if you think about it, is just a logical grouping of these partitions. One of my favorite things about my job is I get to work with customers like yourself to understand not only what problems they face and how they want us to shape the products and services within AWS, but I also get to see the trends that are happening in the data streaming space. My focus is more or less entirely within the data streaming space at AWS, and these are the 5 trends that I'm seeing right now that I'd like to share with you. First is data streams are becoming more increasingly used as a message bus. And the reason that is because they offer the same type of semantics that you would get from a messaging queue, but they do a lot more, which again gives you and your development team option value. If they want to use it for messaging, that's great. But it gives them in the future, if they want to also on the same construct build a real-time application that's, say, stateful, they can do that. It unblocks innovation within those organizations. Obviously, the lower latency is a huge benefit for real-time streaming architectures, and we're seeing a big shift in customers that they're moving from batch processing to continuously processing data as it flows into these data streams. There's a number of benefits to that, including lower costs and obviously the latency that comes with it. Data streams are increasingly being used as a data source for microservices. And the data stream is, it's actually more or less the data store for microservices most commonly. And previously, we saw a lot of customers who might be tying together microservices using queues, but that's really not scalable. The data stream allows customers to drive events into a data stream and source those events out to multiple microservices, add microservices over time without having to stitch together all of these one-to-many relationships between applications. We're seeing a lot of customers build their applications. Instead of building applications on a database directly, they're building applications on change logs that are flowing out of a database. data streaming technologies are capturing those change logs, and then consuming applications are effectively rebuilding the state of the database and running analytics or performing whatever task is required on the change log itself, so that you as a business, you're not having a team kind of contend for those database resources. What you have now is this nice decoupling of the database and those analytics applications that can really work on the change log itself. And then finally, and this is probably not a surprise, is that machine learning and AI is pretty hungry for real-time data. And we're seeing a massive shift in customers who are now starting to either get their hands dirty with ML and AI, or using it, and you'll hear later from Adobe, who is using it in production on Kafka. There are two services in AWS for data streaming. The first, which launched in 2013, is Kinesis Data Streams. That service was built from the ground up as an AWS native service. Last year at reInvent, we launched Amazon MSK to make it easier for you to run Apache Kafka without having operational expertise in running Kafka and Apache Zookeeper, so that you can just focus on building the applications that matter rather than dealing with the muck of operating an infrastructure. There are a number of sessions on Kinesis Data Streams this week. This session will not cover Kinesis Data Streams past this slide. This session will be entirely focused on MSK. If I could summarize why customers are choosing Apache Kafka in 3 reasons, these are the 3 reasons. First is Apache Kafka is very performant. You can scale up Apache Kafka to support a very high amount of throughput, plus you have raw performance in terms of end-to-end latency that's very low. You can not only achieve gigabytes a second of throughput, but you can also get that throughput through the system with P99s in the tens of milliseconds range. Apache Kafka is open source. There's a lot of benefits for that. Portability is one. You can deploy Apache Kafka on the edge in AWS, EC2, other cloud providers. But the other benefit of using an open source is that you, or many of you, are probably contributing to Apache Kafka today or have in the past. You get to benefit from this wide community of developers who are moving Apache Kafka forward. AWS being one of them, and Amazon MSK being one of those contributors to Apache Kafka. Which means that you get to benefit from all of this innovation as a user of Apache Kafka. And also, there's not only on Apache Kafka core, there is an ecosystem surrounding Apache Kafka, like frameworks like Apache Flink and Spark. Those are all tightly integrated with Apache Kafka, so you can benefit from those as well to complete your end-to-end use cases for data streaming. Kafka is very versatile. Because developers like you contributed a lot of great features to Apache Kafka, it makes it such that you can use and deploy Apache Kafka for a lot of different use cases. So those are the 3, there's many reasons why customers choose Apache Kafka, but if I were to summarize them, those are the top 3. However, many of you who've run Apache Kafka on your own, you probably know how hard it is to run Apache Kafka, because you're not just running Kafka, you're also running Apache Zookeeper. It's difficult to set up for production. It might be easy for you to set it up on a developer desktop and get it going. However, having the infrastructure, the automation, and the monitoring in place under the hood is not an easy task. All of that, because it's not an easy task for you to get it ready for production, makes it hard for you to achieve high availability. Metrics don't come out of the box. You have to typically integrate with a metrics provider or build your own metrics solution on top of Apache Kafka. It's difficult to scale. AWS integrations don't come out of the box. You have to build those yourself in most cases. And when you sum all of this up, your use of Kafka is highly dependent on specific developers' expertise with operating Kafka. You shouldn't have to be an expert or have this type of expertise within your company when your end outcome is, I just want to build streaming applications that really matter to my customers in my end business. You don't need to be an expert. These are some of the challenges that Amazon MSK is or will be addressing here in the near future. Amazon MSK is a fully managed service for Apache Kafka, provides you with native Apache Kafka, production ready. All clusters are treated the same. You don't have to worry about, did I make the right choice up front when I provisioned this cluster? Is it production ready? No, all clusters are production ready. It's fully compatible with Apache Kafka. We use open source bits under the hood. We're not forking Apache Kafka in any way, which means that you get exactly what you would otherwise deploy in terms of how Apache Kafka is behaving under the hood for in EC2 or in any other environment. We're also providing you with native integrations out of the box. CloudWatch comes out of the box. CloudFormation, we have an integration with KMS, and we have more integrations coming, and I'll announce a few here later. It's globally available, so if you're a global company and you rely on Apache Kafka, you want that infrastructure to be local to you, and also have a managed service provider that's providing those services local to where you need it. We're currently offering MSK in 17 different regions. I'll pre-announce a few regions, the remaining regions that are public here in a second. So we're going to be offering Amazon MSK in all AWS regions, and by Q1 of 2020, we should be there. You don't sacrifice security, you don't sacrifice configurability, scalability, or high availability when you're choosing to run your Apache Kafka workload on Amazon MSK. And then finally, Amazon MSK, if you do the math, it is the lowest cost provider for Apache Kafka, managed provider for Apache Kafka. And typically what we see our customers paying on a per gigabyte basis all in, and that includes data transfer in and out, is about anywhere between 5 to 9 cents per gigabyte. Large enterprises and startups, a wide range of customers are already running Amazon MSK in production. You'll hear from one of those customers today, and that is Adobe. These customers are using Amazon MSK for a wide array of use cases, from real estate to retail to network security, communications, and recruiting. Since reInvent 2018, we've launched 28 significant new features for Amazon MSK, and we're not slowing down. Right after GA, we announced that Amazon MSK supports HIPAA and PCI compliance. Just recently, over the last couple of weeks, Amazon MSK became ISO and SOC compliant. FedRAMP, by the way, is currently targeted for the first half of 2020. A few months ago, we announced the capability that you could scale up your clusters using the Amazon MSK Console and CLI. There's an advertised limit today. That's soft, by the way. It says that you can provision up to 15 brokers within a cluster. You now have the capability to scale up to 100 brokers within your cluster if you need it. This should provide you and other customers with ample headroom for growth and support the most demanding use cases for Apache Kafka in production. Businesses that run Apache Kafka on EC2 or in other environments, they typically have already instrumented their own metrics pipelines that are grabbing metrics directly from JMX in some form, maybe exporting from JMX. And they use Prometheus as a very common way to either collect or transport those metrics directly from Kafka. I'm announcing that we now offer support for Prometheus through open monitoring, which allows you to, if you're using a third party like Datadog, Sumo Logic, New Relic, Lenses, to export your metrics directly from Amazon MSK and land those in these providers, and so that you can continue to use those metric solutions that you otherwise would have had in EC2 or in some other environment. Apache Flink is becoming one of the most popular frameworks for processing data in Apache Kafka. However, if you wanted to use Apache Flink and process data from Kafka, you had to manage Apache Flink on your own. Well, that's no longer the case. You can now run fully managed Apache Flink applications, not only against your Amazon MSK cluster, but also on your cluster that might run an EC2. And this capability is available today. And if you're not familiar with Flink, Flink is a very powerful stream processing framework, and it makes it easy for developers to build high-performance, stateful data streaming applications using SQL, Java, and Scala. Now, like I mentioned, you would have to otherwise stand up the infrastructure that supports Flink on your own, monitor that infrastructure, also design that infrastructure to recover, and also scale. Kinesis Data Analytics for Java, which is the service that runs Apache Flink for you, does all of this for you. It elastically scales. You just simply provide the application, your VPC settings, to connect the application to, and we take care of the rest, and you just pay for your usage on demand. There are a few features that are coming soon. I mentioned we're going to be offering Amazon MSK everywhere. The last regions are the GovCloud regions, China, and Bahrain, and those are coming in the first half of 2020. We'll be delivering broker logs directly to CloudWatch so that you have a better way, an easier way to troubleshoot your applications. We'll also allow you to kick off an in-place upgrade on your Apache Kafka cluster to go from one version to the next. And by the way, we'll be supporting 2.3 here by the end of the year. And then support for 2.4 will follow shortly after. SASL is a very common authentication mechanism used by customers, and we'll be supporting that as well. And then finally, if you're looking for a lower cost instance type within Amazon MSK, or something that is a better fit for lower volume workloads, we'll be supporting the T-Instance family for that. With that, I'd like to invite Anand from Adobe up to the stage.
Thank you, Damien, for the wonderful introduction to data streaming, Kafka, and MSK. Hi, everybody. My name is Anand Phatak. I'm a software architect at Adobe. Today, I'll be talking about our use case of using Apache Kafka inside Adobe for our products and services. I'll first talk about Adobe Experience Platform. I'll see what this is about. Then the Adobe Experience Platform pipeline, which is our solution on top of Apache Kafka, offers a lot more functionality on top of Kafka. The challenges that we face in running Kafka at our scale. Damien mentioned some of those challenges, and we absolutely face them in our production environments. We have some of the best Kafka experts in our team. I'm proud to say that. We operate our own clusters, but we are expanding at a very rapid growth, and we are required to create new and new clusters almost every month. And that is where MSK has come to help us. So my colleague Adrian will walk us through our journey of adopting MSK in Adobe. So let me begin by talking about our scale. We process upwards of 100 billion messages per day in Adobe. We are live in 15 data centers, Kafka clusters across the globe, and these are production clusters. The number actually is much higher if you consider the integration and staging environments. We operate on multiple clouds, and obviously AWS being one of the prominent ones. There are around 200 Kafka brokers, which serve around 25,000 topics, close to 300K partitions, and this number is growing rapidly every day. So you might wonder, why does Adobe require such a big messaging system? So how many of you know Adobe for our creative products such as Photoshop, Illustrator, Premiere Pro? Almost all of you. Do they need a messaging bus? Well, I can tell you that yes, these products do need a messaging bus, because that's how we find out how they are used. which features are popular, which are where customers are facing some difficulties. But then, does it really roll up to this particular scale? Our products help creative professionals to create some of the best looking assets, images, videos, illustrations. And those assets are used by Adobe's customers to build their websites, their mobile applications. And through those websites, mobile applications, our customers sell their products, their services to their customers. But in today's age, when you sell services, you're actually also selling customer experiences. Was your customer experience good when the customer came to your website? If the experience is good, then you will get a repeat business. If the experience is bad, maybe the customer won't return. But what is a good customer experience? And can that be delivered in real time? And if it is not delivered in real time, what happens? So let's watch a short video.
Target's been neutralized. I'm heading to the hotel. Checking into the penthouse. The name's Hunter.
Certainly, Mr. Hunter. I have your reservation right here.
Wait, did you say Hunter?
No, I don't have a Hunter.
But you emailed the confirmation to my watch.
Well, marketing handles emails. Oh, I have a Hanson.
No, it's Hunter.
Hunter.
I picked my room on your app.
Oh, we have so many apps, like the...
But I'm a platinum member. I even have a promotion from your website.
Promotions are on a different system, but I do have a single on the ground floor, Mr. Hanson.
It's Hunter. My name is Hunter.
Well, that was a pretty bad customer experience, even though the hotel probably had all the information about the customer, but they did not have it in the real time. Maybe their systems talk to each other in batch uploads, we don't know. But imagine a world when Mr. Hunter walks into the hotel, and just by being in the proximity of the hotel premise, his cell phone sends an event real time to the hotel reservation system, the check-in system. And they find out that, oh yes, we have a reservation for Mr. Hunter. And that system checks in Mr. Hunter, sends a push notification to his phone, and he sees that he's been allotted to a specific room number, which is his penthouse suite. He walks to the elevator, takes the elevator, goes to his hotel room, opens the hotel room with his phone, and in the meanwhile, at the same time, another event is fired in real time. That event gets enriched along the way, and that has more information about Mr. Hunter, that he's the platinum member, and he has certain likes, maybe he prefers certain drinks, and that event is sent to the foods and beverages system. They prepare his complimentary drink, send across to his room. He's a happy customer. Bad guys don't find out where he went. That's a great customer experience. But then, how do you deliver such customer experience? That's where Adobe Experience Platform comes into the picture. So we built this platform which can capture customer interactions on the edges, which are close to your customers, in real time, in millions of events per second. It can generate a real-time customer profile based on the past interactions of the customer with the business. For example, in our case, this customer walks into the hotel and they know what his preferences are. His phone probably produced an event which was a very tiny event, but got enriched in real time as it passed through. This platform can run machine learning and AI in real time. For example, a customer on the retail website trying to buy a product, and she clicks on an image. The platform can actually run ML in real time to see what's inside the image, not the text, the actual image, and finds out that, hey, this customer has bought certain products which look similar, and she's probably going to buy this. So you can instantly show some promotions or discounts. So this platform can analyze this data and provide some rich and relevant experiences in real time. And the key here is real time. You need that in the millisecond latency. And that's where we have this experience platform pipeline, which powers our experience platform. And this is our Kafka-based messaging bus. We call it as our data power grid because, as I showed you in the earlier slide, we have a global presence. We are present in every region. They are all interconnected data clusters, Kafka clusters. So what pipeline can do, it's on top of Kafka. It can integrate services, obviously, by breaking down silos, making the integration possible. For example, again, going back to the hotel case, the promotion system, check-in system, reservation system, they can talk to each other in real time. It can enrich data as it flows over the pipe. It can invoke custom business actions and logic on individual messages. And I'll show you in brief how that is done in pipeline. Some features of our pipeline are the REST APIs to produce and consume messages. Yes, we use REST APIs. Because they are firewall friendly, you don't need to open certain firewall ports to allow native Kafka traffic. They offer loose coupling. You are not bound to a specific programming language, being REST APIs. Data flows encrypted over TLS. The APIs accept the standard OAuth tokens, so data is secure. One of the very popular features of pipeline is intelligent routing. What does that mean? It means that the producer, when they produce to a specific Kafka cluster, the message could be read by a consumer which is totally in a completely different geographic zone. And the producer doesn't need to know where this message needs to go. That is, when we put a message onto Kafka topic, it has a header part and the body part. The header part is the control plane, body pass, data plane. The pipeline service has intelligence built inside, which can find out where this message needs to be delivered. It can offer message filtering, because this is a shared infrastructure in our company. So there are many services that use common topics. There could be, it's a multi-tenant topic, for example. And some consumers, when they want to consume from these topics, they don't want to consume the millions of records. They want to consume only certain that they care about. And pipeline offers filtering. Again, I'll show you in brief how that is done. This is a 10,000 feet view of pipeline infrastructure. In this case, I'm showing a data center, London, in which we have a Kafka cluster. In front of Kafka cluster sits our Edge API service that exposes the produce and consume APIs. On the left is a service that is producing a message to the pipeline Edge API by calling its post API. The service takes the message, writes to the Kafka topic. Similarly, a consumer can open a consume connection in the pink arrow there, and it calls get some data from the topic. It opens behind the scenes a Kafka consumer and starts consuming messages. And this is a long polling HTTP connection. The connection doesn't close, so you can start streaming messages on the same consume connection. That's a simple use case for single data center. Now I talked about routing. How is that done? So in this case, there are two data centers. One is London on the left, Tokyo on the right. A service in London data center is producing to the pipeline Edge API. Now, based on the message header, the service finds out that, hey, this message has, the certain rules get fired, and it finds out, oh, by the way, this message needs to go to Tokyo. So instead of writing to the local topic, it writes to a shadow topic behind the scenes, and the producer doesn't know about that. And the shadow topic is mirrored across different clusters. So there is a mirror maker sitting in Tokyo that pulls that shadow topic information, produces data on the local topic, and the service sitting in Tokyo is now reading the data from thinking that it actually was produced in Tokyo, but it was actually produced in London. Now you might ask, what is the use case for such a setup? Well, if you have a global presence, your services could be deployed in different regions. For example, in our use case, we send marketing campaigns. The campaign authoring system sits in one location, for example, London, but the actual campaign delivery systems are on the edges. So when you get a push notification, for example, that could be coming from a local edge. So the campaign authoring system produces messages on one data center and then get routed intelligently to the entire grid, depending on where it needs to go. Similarly, a producer in Tokyo can produce to Tokyo data center, and then it can consume from London, and this happens across all the data centers. And as we add more, this capability is automatically extended to all data centers. The filtering part I mentioned about, this is how it works. There is a Kafka cluster, and there is a common topic. It's a multi-tenant topic, for example, has a lot of messages in it, yellow message, green message, red message, for example. But the consumer who wants to consume doesn't want to consume all this because maybe he's interested only in 10% messages. So it calls the GET API, says, hey, filter for me only green messages. And the API service will now open a connection to Kafka, read the topic, take away any other messages than green, and just send the green messages back to the consumer. And this way, the consumer is not overwhelmed. There is no wastage of network bandwidth or storage, and the consumer is now able to get only the messages that they are interested in. In our ecosystem, we also do stream processing. First, we use Kafka Connect to bring in data. We require a lot of third-party data in our systems. So we use Kafka Connect, which can connect to third-party systems, such as databases, CRM systems, and there are many open connectors available in the market. You can write your own if you want to. That gets data into Kafka, and also we can export data from our Kafka topics to external systems using Kafka Connect. We use Apache Flink, as Damien mentioned briefly how Flink works, what Flink can do. It can do advanced event filtering. It can do data transformations, because service A may understand one format, service B may understand second format. However, we have tried to standardize the data formats, but it's still always not the case. So you can do transformations. You can do complex branching that you read from topic A, and then you can write to topic B, C, D, depending on your use case. And this is how that works. We have a Kafka cluster, and there is a source topic with lots of messages on it. Using our console UI, it's an application that we have built in-house again. Administrator can spin up streaming services and can mention steps inside that, hey, filter out message 1, call the Lambda function, enrich the message, write back to the topic, and the message now gets to the destination topic. For example, going back to the hotel use case, customer walks in, we know a little bit about the customer, but the data enriching happens in real time, in milliseconds, and we know a lot about the customer, and then a good experience is delivered. And then finally, there is a self-service console. Being a shared infrastructure, we have to make sure that we offer easy way of creating topics, looking at metrics and charts, maintain routing rules and management. But with all this, you can imagine how our scale is going up to 100 billion messages, every small customer interaction getting captured. And we are growing at the same time very fast. And creating new Kafka clusters is very hard. That's where MSK really comes to our rescue. And I'll invite Adrian to walk us through our adoption of MSK.
Thank you, Anand, and thank you, Damien. Hello, everyone. My name is Adrian, and I'm a software engineer at Adobe. Today, I will introduce you to our journey on adopting Amazon MSK. As Anand mentioned earlier, Adobe Pipeline is the data power grid for some of the most important applications available in the Adobe Experience Cloud. And this translates to a large number of deployments spread across the globe, across multiple data centers and cloud providers, AWS being, of course, one of them. And all these sites, they must be interconnected to achieve that intelligent routing also mentioned before. So zooming in one of the regions, it will look more like this. Each Kafka cluster has multiple in and out connections. We use Mirror Maker to ensure connectivity between pipeline sites. Here, I represented 4 of them, but actually, there are connections with every other 14 pipeline sites, since this is a full mesh architecture. And we expand to more and more regions every year. On top of this, we also have the pipeline API, the HTTP adapter also mentioned before. I know that this may sound a bit crowded, but Actually, it's manageable because both the API and the Mirror Maker instances, they're handled by our team. And in time, we learn how to operate them to avoid any damages into our system. But Adobe Pipeline is an Adobe internal service, and being an internal service requires some flexibility. Our customers are dozens of solutions across the Adobe ecosystem. And some of these customers, they do not want to use the HTTP wrapper. Instead, they want to use Kafka natively. Maybe they run a Spark application, and that would indeed integrate easier with Kafka native interface. And they are also our colleagues, so we cannot say never, no, right? So we had to allow both direct produce and consume in our Kafka clusters, which not only that it increased the number of connected applications, but also introduced some consumers and producers that are no longer in our control. As you can imagine, it takes only one noisy neighbor to unbalance the entire cluster. And through our history, we had several such incidents. So looking for solutions to isolate these noisy clients, we came up with this approach. Basically, this is a hub and spoke architecture. We split the original and single Kafka cluster into several clusters. The main one that we call backbone has only trusted in and out connections like the Mirror Maker or the HTTP adapter. And for direct produce and consume workloads, we build dedicated Kafka clusters that we call satellites. This solution is pretty natural and is not that complex either, but it introduces an entire new problem. The number of Kafka clusters will literally explode. We have some hard times operating one Kafka cluster per region, and with this new approach, we'll have to handle and provision dozens of clusters, an entire fleet of clusters in every region. Now, Adobe Pipeline team is already operating today dozens of Kafka clusters, and we're doing a pretty good job. And that's why we can also tell you that this is not an easy job. We spend a lot of time in day-to-day operations, like scaling out, node replacement, cluster upgrades, or cluster rebalancing. And due to lack of automation, it's very hard to quantify and predict all these costs. So, new challenge. What would it take to get a one-click deployed, self-managed Kafka cluster? Analyzing our options, Amazon MSK got our attention. Kafka as a service model felt like a natural fit for our needs. We could just replace our own deployment with MSK and continue to use and operate all our tools and applications with very little changes. And we could delegate all those operational tasks that I complained about earlier to AWS. And on top of this, we would also get a predictable cost model. So Amazon MSK would help us with the easier management of the clusters. But what about the easier deployment? We have some checkboxes here as well. The first one, we have to integrate it with our technical stack. Running the vanilla Kafka, the Apache Kafka, helped us a lot here since we could continue to use our tools without major changes. Mainly, this was a lift and shift operation. Also, the deployment had to be resilient and consistent. The multi-easy nature of MSK plus the EBS-based storage was the answer for resilience. And the ability to configure the cluster through code like the AWS API, or in our case, Terraform scripts, would be the answer for a consistent deployment across multiple data centers. And I was also telling you that we plan to deploy a lot of clusters. The ability to create clusters on demand is essential. And let's see how we do it. We use Terraform to deploy the base, networking, MSK cluster, a Kubernetes cluster, an EKS cluster, where all our application will run later. And we also use Terraform to peer the MSK and DKS VPCs. On top of this, using Helm and Compose, Adobe developed open source tool, we deploy a series of what we call infrastructure applications. They handle metric collection, logging, DNS resolution, disaster recovery, and many others. By the way, Compose is available in GitHub. Please take a look and let us know what you know. It's a tool to deploy Kubernetes Helm charts. Finally, using Spinnaker, we get to deploy our pipeline applications. As you can see, this is not a one-click deployment yet. But we are working to transform all these steps into a Spinnaker pipeline, and eventually, this will become a one-click in Spinnaker UI deployment. As you can imagine, adopting MSK has some challenges, though. First of all, we had a very strict timeline. Our mission was to deploy a new pipeline site in AWS in Japan by October, and we were in June. So we had less than 5 months to evaluate MSK, find a way to integrate it, and have a production-ready deployment. And with AWS help, we managed to be development ready in September, 1 month before our deadline. I want to pin these dates because some of the challenges that we faced back then might have already been addressed by now by the MSK team, since MSK continues to evolve. I was telling you that our mission was to deploy a new pipeline site in Japan. And we took this opportunity to deploy what we call Pipeline 2.0. Basically, it's that mix of Kubernetes and MSK that I showed you earlier. And this infrastructure upgrade should be transparent for our clients, right? They would expect to have the same functionalities in the new sites as they used to have and as they still have in the old sites. And they would also expect to get the same monitoring level. And since our customers are usually power users, we offer a lot of visibility in our Kafka clusters. Our own monitoring stack is based on Prometheus and Grafana. MSK, on the other hand, has its own monitoring stack based on Amazon CloudWatch. Matching the two solutions turned out to be quite challenging, and we end up with a temporary gap in our metric system. Fortunately, the recently announced Prometheus exporter should help us close the gap and align all the pipeline sites. We also had to be open-minded and be ready to adopt some of our architecture. Amazon MSK is served as a service. As a user, you cannot access the virtual machines. You cannot drop custom jars, and you cannot start Kafka with a custom Java agent. And this might be a blocker from using some tools like LinkedIn Cruise Control. Okay. Another challenge that we faced back then was the team mindset. As I mentioned, we operate dozens of Kafka clusters. We are used to debug the problems ourselves. We deep dive into Kafka logs and metrics and find the issues and fix the issues ourselves. MSK, on the other hand, again, is a service. Fixing the problems involves rather good communication with a service provider, making them understand the problem that you're facing, and working together to find a solution. A different approach, but we're getting used to it. And finally, back in September, scaling out was not yet available for Amazon MSK. You could increase the storage for the brokers, but you could not add more brokers to an existing site. And as Damien mentioned, this was recently fixed, but back then we had to plan our original provisioning to include both the organic traffic increase and the seasonal spikes that were approaching, including Black Friday, Cyber Monday, and of course, winter holidays. And speaking about winter holidays, we wrote a sort of wish list with some of the features that we'd love to see from MSK in the future. I think I hit a button wrong. Guys from the backstage? Okay, I don't have the slide, but I can see it's like it was my last slide, so it's fine. So one challenge was the metric, and fortunately, it got fixed. Yeah, it doesn't matter. And another challenge, I was saying about the cluster scaling. Scaling out is available today, but as some of you might know, scaling out your cluster brings you little advantage without rebalancing the cluster afterwards. Since we cannot use some tools like LinkedIn Cruise Control, a self-balancing feature from Amazon MSK would help us to go to that self-managed Kafka cluster that we are aiming for.
Sorry, I don't know where you were.
No problem. We also look forward towards scaling up our clusters and be able to add multiple EBS brokers, and that would help us for the larger deployments that we have on our roadmap. And finally, rolling upgrades. MSK follows pretty close the Kafka release calendar, but without the ability to upgrade in place the clusters, we cannot use the latest offerings, the latest Kafka offerings on the already deployed Kafka clusters. As you can see, we still have a lot of work to do to achieve that one-click self-deployed Kafka cluster, but I think that we're going into the right direction, and eventually we'll get there. Thank you.
Thank you. Do you have the clicker? That's over? Okay. Love the candid feedback. Thank you. And those items are on our roadmap. We're working on them. Thank you for joining us today. This is probably a familiar slide. If you're looking to learn more about a number of the analytics services, we have a great training and certification program. Visit that link. We'll be available for questions. If you have any, just meet us over here on the side of the room, and we'll do some quick Q&A. Thank you.